problem number 5 talks about Oscar, who's hunting magnetic fields with his Gauss meter, which is a device for measuring strength and polarity of magnetic fields. It talks about how the reading on the meter is increasing as he gets closer to a magnet. The Oscar is in a long hallway, at the end of which is a room containing an extremely strong magnet. When he's far down the hallway from the room, the meter reads a level of 0.2. He then walks down the hallway and enters his room. He's gone 6 feet into the room and the meter reads 2.3. When he goes 8 feet into the room, the meter reads 4.4. Give a linear to linear rational model explaining the meter reading y to how many feet x Oscar has gone in the room. So basically what we need to do is we have our model here, which is y is equal to a times x minus b, or ax minus b over x minus c, and we need to do basically solve for a, b, and c. So we know a is 0.2 because the problem basically gives it to us. It says that when he's really far down the hallway, or essentially outside of the magnetic field, it reads 0.2. So then we can just plug in 0.2 into our equations, or given the points that the problem gave us. So one of the points is 620 or 2.3, 6 comma 2.3. The other one's 8 comma 4.4. We got that by just where it says when he's gone 6 feet into the room, it reads 2.3. So we plug 2.3 in for y, and then 6 for x, and we get 2.3 times 6 minus 2.3c is equal to 1.2 minus b. So we solve for b, and we get 2.3c minus 12.6. Then we use our other point, plug those in, and but this time for b, we go ahead and plug in what we just found over there. So that's what we get before we plug in b, and there we plug it in, and then solve for c, and then c should equal 10. Then you come back to the formula, or what we found for b. Given c, plug c in, and then you get 10.4. So that leads us to, if we plug a, b, and c into that, we get 0.2x minus 10.4 all over x minus 10. So then what it asks us to do is how far must you go for the meter to reach 10 and 100. So we just set y equal to 10, and then solve for x, and for 10 we get 9.142 meters. And then for 100, same thing, except now we get 9.916 meters. And then it asks us where do we think he was basically at the start of the problem, and I said he was 10 meters out because that's basically where it started increasing in the magnetic field. Once he's 10 meters in, it's pretty much maxed out.